Welcome to this operations management tutorial video on break-even analysis and process selection. In this video we're going to show you how to compute the break-even point via three different methods. The total cost method, or trial and error, a break-even using a break-even equation, and finally using Excel's goal-seek functionality. Now we're going to jump into Excel, and the examples we're going to be using are right out of the textbook. In this example we want to manufacture large bolts, and we have three different options to do so. The first is using a standard lathe, fairly general purpose type of lathe with a cost of $1,000, a fixed cost. The variable cost per bolt is going to be $3. Or we can go to a little bit more automated process with a CNC, computer numerical controlled lathe. It costs us a little more to purchase this lathe, $2,000, but the variable cost per bolt is going to be a little lower at $2. Or finally we can go to a highly automated, very fancy, dedicated lathe. It's going to cost us $4,000 up front, but the variable cost per bolt is even lower at $1.50 per bolt. So to compute the total cost, we're going to begin with the standard lathe with a volume of 0 units. So we know the cost is going to be 1,000, but we're going to write the formula here and show you how this is done. So it is equal to, we take the fixed cost of the lathe plus, and then open a parentheses, the variable cost per unit times the number of units produced, 0, close parentheses, and that's going to be equal to 1,000. Now in order to copy this cell or this formula across all the cells in this table, I have to do some anchoring of cell, or rather of column and row references. So for example, and what I mean by that is, we want to make sure all of these cells to the right in their formulas are referencing the standard lathe fixed cost. We also want to make sure that they are referencing the variable cost. And we also want to make sure, as we copy down, that we're referencing the row that contains the unit volume. Now this might be a little confusing, so I'm just going to walk you through the process here. So we need to put a $sign in front of the letter C, C4, and so as we copy the formula to the right, the new formulas in these other cells will retain the reference to the $1,000 fixed cost. We also need to put a $sign in front of the D in order to retain the reference to the variable cost. And then finally we need to put a $sign in front of the 3 in order to retain the row reference of row 3 as we copy the formula down. So I'll hit enter. It didn't change the result of that formula, but now we're going to drag this to the right, and I'm going to do it without changing the formatting. And so we can see that if I click on any one of these cells, it retained the reference to the fixed cost in column C and the variable cost in column D, and of course we did not copy down to rows 5 and 6, so it still retained the row reference to row 3 in the volume. So now that I have those formulas written and copied, I can copy it down through the rest of the cell, rather the rest of the table, and there we have it. We have the costs filled out for each of these options, and you'll notice if I click on the dedicated lathe with a volume of 3,000, it's still referencing the proper fixed cost and variable cost from columns C and D respectively, and it also retained the unit volume from row 3 because again we have the $sign in front of row 3. So we just did this little spot check to make sure our formulas copied correctly, and it looks like they have. So as we look at this table, notice that at a volume of 1,000 units we get the same total cost for the first two options, namely $4,000. Likewise, at a unit volume of 4,000 units, we get the same total cost for the second and third options. Now, if we graph these results, we can see conceptually what is happening. And what this graph tells us is that the lowest cost is the lowest line throughout the range of volume. So for volumes up to 1,000 units, we are best served by buying a lower cost machine or the standard lathe, where the red line is the lowest line up to 1,000 units. From 1,000 units up to 4,000 units, the green line representing the total cost at those volumes for the CNC lathe, that is the lowest total cost, and so that would be the best option if we anticipated our unit volume being somewhere between 1,000 and 4,000 units. And of course, if our volume were expected to be above and beyond 4,000 units, then the dedicated lathe would be the best choice, where we would have plenty of unit volume to overcome the higher fixed costs and recoup those costs through a lower variable cost of $1.50 per unit. Okay, well, let's move on to our next example. How do we determine the break-even point when we don't have such nice round numbers? Well, we are going to look at two methods. One is using a break-even equation, and the other is using goal-seek. Now, the break-even equation, as found in the textbook, is equal to the fixed cost of one process minus the fixed cost of another process divided by the variable cost of the second process minus the variable cost of the first process. So to do that, I'm just going to write this into Excel, and I need to open up parentheses to make sure we have the numerator and denominator isolated. So we're going to take the fixed cost of one process minus the fixed cost of the second process, the CNC lathe, and then we're going to divide that, and again I'm opening and closing parentheses as needed, the variable cost of the second process minus the variable cost of the first process, the standard lathe, and that gives us a break-even point of 1,000. Again, this matches what we saw in the previous method where we did trial and error and filled out that table. So we have nice round numbers in this case. Okay, so if we put 1,000 up here, just at our unit volume, just for fun, you'll notice that it gives us the same total cost for the standard lathe and the CNC lathe. Alright, let's do the same formula between the CNC lathe and the dedicated lathe. So again, we're going to open up a parentheses equal, open parentheses, the fixed cost of one of the processes, we'll start with the CNC lathe, minus the fixed cost of the other process, the dedicated lathe, divided by, open another parentheses, the variable cost of the other process, the dedicated lathe in this case, minus the variable cost of the CNC lathe, and close parentheses, and there we have it, 4,000 units, which matches what we saw in the other exercise as well. And if I put 4,000 here, the volume, you'll see again that the total cost between these two processes match. Alright, well that was fairly straightforward. Let's move on to goal-seek. And so here we have goal-seek. And again, we have our table from before. We know what the answers are going to be, but we're going to use goal-seek to derive these answers. So what we've done is we've created a formula here where we have the difference between the standard lathe total cost and the CNC lathe total cost. And so we've just taken the 1,000 minus the 2,000, that gives us a negative 1,000. And then we do the same thing, the CNC minus the dedicated total cost. That's 2,000 minus 4,000 gives us a negative 2,000. What we want to do is we want to see what the numbers would be if the cost between each of these two processes is the same. So what is the volume that will give us zero difference between the standard lathe total cost and the CNC lathe total cost? To do so, we begin by clicking on the cell where we have this difference formula, and we go up to our data tab in the ribbon, and we move over to what if analysis, and we click on goal-seek. And so our goal in this case is to set the difference cell C8, to a value of 0. We don't want any difference between the total cost of these two options by changing the total volume, or the volume we anticipate. And so we click on that cell and click OK, and let Excel do its magic, and voila, we have an answer of 1,000 units. Of course, that matches what we saw before. At 1,000 units, there is no difference in the total cost, 4,000 each, and so that is our break-even point derived using Excel's goal seek function. Okay, well, let's do it now for the difference between the CNC and the dedicated lathe. Same thing, I'm going to click on that cell, and we want to invoke goal seek once again, what if analysis, goal seek, and we want that cell set to a value of 0, so there's no difference between the total cost of these two options, by changing once again the volume we anticipate. Click OK, and there we have it. Excel gives us the answer of 4,000 units. Well, that ends this tutorial video on how to compute the break-even point via total cost, the break-even equation, and goal seek. I hope this has been helpful for you.